Thank you very much for joining again. And now we are going to move on to our question 10. As what we have discussed this morning, we have done with question 9, and now we are going to question 10. Okay. Now this question 10 is about the rate of reaction, a question which is where you are familiar with it. Okay. Now based on the table, you compare the rate of reaction in the first minute and the second minute. Now you might have problem about the first minute and the second minute. What does it mean? Okay. First minute means from here, let's say I am drawing a number line from 0 to 1, from 1 to 2. Now the first minute means it is from 0 to 1. This is first. From the 1 to 2 here, this part here, this part where I put it in green, this is the second minute. This part. The second minute. Okay, so now what can you do? Number one, you can actually calculate. This is in second. So first minute means from here to here. This one. Second minute means from here to here. Okay, from here to here. Can follow? From to the 120. Okay. Now actually, if you are calculating, you are actually taking the 5 minus 0 over 60 seconds. What is your answer? Someone do for me. Someone do for me. Someone do for me, please.
0.03.
0.03, and we are getting the unit as centimeter cube per second. Now, what about the second minute? Someone do for me. Second minute, do you know how to calculate?
I told the answer. I minus it and told the 0.03.
0.03 is for which one?
I minus 6.8 minus 5 over 60 seconds.
Minus 5. So this is for the second minute.
Nice.
Okay, thank you. Now, what about the first minute? We are taking the 5 over 60.
0.083. 0.083.
0.083 centimeter cube per second. Okay, now compare. Can you see this number is bigger compared to this? Meaning to say, the rate of reaction in the first minute is higher than the second minute. Now, actually, we have already mentioned about this previously. Do you remember that during the very first lesson of the rate of reaction, I talked about this graph. I put for you point A and point B. And I say the rate of reaction at A is higher compared to the rate of reaction at B. Okay? So now, what is the reason? We are now going to compare, then we are going to explain. Actually, when I ask you to do this calculation, this is already the explanation. So now, you see, how do you get the marks? Number one, you have mentioned about the comparison, where the rate of reaction at the first minute is higher than the second minute. Done. Point number two, you calculate for the first minute, this is your value. For the second minute, this is your value. You are getting already 3 marks. So what is the next marks? We know that the nitric acid react with excess magnesium in this reaction. So which one will be used of? The nitric acid or the magnesium? Can I have response from you?
Magnesium.
Yes, the magnesium will be used up. Are you sure? Who answered magnesium just now? Will the magnesium use up? Did you see the word excess? Excess means too much already. Excess means too much. It will not use up. What will be used up is the nitric acid. Okay, therefore, we are now going to say that why the rate of reaction at the first minute is higher Then the second minute, the reason is the concentration of the nitric acid decreases. I repeat, the concentration of the nitric acid decreases. Okay, I hope you are with me until here. Now we continue. Next part of the question. We are now at part 2. Calculate the overall rate of reaction. Now, what's the difference between the one at 1 and the one at 2? When we are talking about overall rate of reaction, look at the table, look for the maximum volume of gas, which is 8.1. Can you see? You have 8.1 here because they recorded until the 240 second. But when does the 8.1 started to be collected? It is at 180 seconds. Therefore, your average rate of reaction is actually taking the volume over time taken, which is 8.1 centimeter cube over 180 seconds. Okay, so this will be your answer. And your final answer, I hope you get it as 0.045 centimeter cube per second. Okay, please have the unit written. No unit, no marks. Okay, now we continue for the next part of the lesson where we are going to talk about part C. Okay, the following equation represents the reaction between the hydrogen and the oxygen. Can you see the word explain? Explain means you have more than one sentence. Effective collision can produce water molecule. Now, the keywords here, effective. Effective means it will produce a product, which is the molecule of water. Now, how does this occur to give the water molecule? Of course, when we are talking about effective collision, collision will occur. What are the particles which collide with each other? Can I have response from you? What are the particles which collide with each other? Who can tell me?
Hydrogen gas and oxygen gas.
Hydrogen gas and oxygen gas. Okay, now our friend said hydrogen gas and oxygen gas. But I am asking the type of the particles which collide with each other. Now, when I am talking about particles, your answer must have the word atom, ion, and molecule. Can follow? Okay, so what is the particles for the hydrogen gas? What particles is that? Hydrogen gas consists of what particles?
Molecule.
Yes, good. So it is the molecule. Okay. And what about the oxygen gas? It consists of also molecule, right? So we are going to tell for the first point, the hydrogen molecules collide with the oxygen molecules. From where we can get to know the particles which collide with each other, it is actually from this part. Okay. From the chemical equation, we write the ionic equation. Now, in this case, the chemical equation and actually the ionic equation, it is the same, which is this part. Okay, so for the first point, the hydrogen molecule collide with the oxygen molecules. Okay, now when it is effective, it must fulfill two requirements. Requirement number one, long time we didn't mention about this. Requirement number one, it must be at the correct orientation. Correct orientation means, in simple word, it is about the arrangement. So your second point, you are going to tell the hydrogen molecule and the oxygen molecules collide with each other with the correct orientation. Then number two, you are going to relate to the activation energy. Okay, so how do you explain about the activation energy? You can say that the hydrogen molecule and oxygen molecules achieve the activation energy. It can be minimum or it is higher so that it can turn to become the product. I repeat, when we are talking about effective collision, point number 1, you talk about the collision. Who collides with each other. Number 2, you talk about correct orientation. And number 3, you talk about the activation energy. So this will be your answer. Okay, now we are now going to move on. Next part, we are now going to look at C. It shows the apparatus set up for experiment 1 and 2, and it is in both experiments, the time taken for the mark X to disappear from site is recorded. I hope you still can remember this reaction where we have already done it in our lesson. Now, first of all, I would like you to write the chemical equation to represent this reaction. Okay, now this is for you to recall. The sodium thiosulfate having this formula, the sulfuric acid H2SO4. Okay, now as what I always say, you cut half, positive, negative, cut half, positive, negative. So the positive from the front will take the negative from the back. Na positive, Dichen, this one, take the number 1 cross it, take the number 2 cross it. So you are actually getting Na2SO4. Don't forget the sulfur dioxide and water. Okay, then you check the answer whether balanced or not. Now in this case, the reactants are the sodium thiosulfate solution and the sulfuric acid. The sodium thiosulfate solution initially is put into the conical flask. Then you add in with the sulfuric acid. Okay, now what is next will be this. The question shows that for set 1, time taken is 30 seconds, and for set 2, the time taken is 15 seconds. Okay, look at the condition here. Can you see they are all the same? They are all the same. So now the question is asking you, suggest 2 factors that can affect the time taken for the mark X to disappear from site in experiment 1 and 2. Now, if you want them to be of different rate of reaction, okay, the factors that you can talk about it in this condition will be the number 1, the temperature. Okay, meaning we are going to put set 1, experiment 1, higher in temperature. Okay, and for set 2, lower in temperature, if we are talking about temperature. Now we can also change the concentration. The concentration can also, okay? Can, if we are talking about concentration, we are still going to put this set 1 to be of higher concentration, set 2 to be at lower concentration. Now you might say that, oh, this one and this one the same. So which concentration can I change? You can actually change the concentration, no problem. When you want to change the concentration, you are going to add in still water. Okay, now we continue. We have already done about the factor. Now we are now going to move on to the next part of the question. Describe how to carry out this experiment in 1 and 2. From the collection of paper 3 that I have given to you, this experiment is inside there as well. But I want you to take note about number 1, you are going to, first of all, you are going to heat this solution. Let's say you want to talk about temperature. You are going to heat this solution starting with 30 degrees Celsius. Okay, then you repeat the steps. Mention what are the steps. By heating the sodium thiosulfate solution to 35 degrees Celsius, 40, 45, and 50. And previously in one of our lessons, I've also mentioned about this already. That's why I don't repeat. Okay. Now overall, what you are going to do is, number 1, you are going to measure and pour. Can you see the 50 and the 1? Use this. Okay. of sodium thiosulfate, this one is for the sulfuric acid. I'm sorry. Okay, this 50 centimeter cube, you are now going to add in your own concentration. You can put 0.5, you can put 0.2, no problem. Okay, let's say I'm using this 50 centimeter cube, 0.5 mole per decimeter cube of sodium thiosulfate solution into the conical flask. Then you are going to heat it to 30 degrees Celsius, place it onto a piece of paper with a mark X. Then you are going to add in sulfuric acid. Talk about the volume and the concentration, okay? Quickly. Then you start your stopwatch immediately. Have to have the word immediately. Some of you in your answer you don't put immediately. Start your stopwatch immediately. Then you swirl. You observe to record the time taken for the X mark to disappear from sides vertically above the conical flask. Then you stop the stopwatch. Repeat the steps by using this temperature. Don't exceed 50, please. Okay, this is about the temperature. If you want to talk about concentration, then you don't talk about heating it. Just use this. Then you are going to add in water, distilled water. And you are going to make a table. Make a table as what we did in our report. The concentration, the volume of Na2S2O3. Write the concentration there. Then the second one is the volume of distilled water added. And you are going to put set 1, set 2, set 3, set 4, set 5. How much of water is added? Set 5. Okay? Refer back to our report that we have done previously. So this is the answer for the describing of experiment. Any problem until here? And of course, you have to write the chemical equation. The question asks you to write so, right? There, can you see? Okay, no chemical equation. If you want to write, yes, no problem. I repeat, whenever the question asks you about a reaction where you can show the chemical equation, you please show. Okay? Any problem for our lesson today? You may ask now. Any? No, okay. So this is the end of our lesson today. I have to keep to the time. Okay, thank you very much for joining. And we will meet for the next session.